What if everything you thought you knew about where we came from and even when we came from was wrong? Imagine an object ancient beyond comprehension silently cruising into our solar system, behaving in ways that shatter fundamental laws of physics, only to vanish behind our star for 8 days, hidden from every single eye on Earth. Then, when it reappears, its baffling behavior has seemingly corrected itself. This isn't science fiction plotting. This is the reality we've been grappling with since October 29th, 2025. At 7:47 in the morning Eastern Time, the interstellar comet designated 3I-ATLAS reached its perihelion, the absolute closest point to our Sunday. We're talking about 203 million kilometers away from the Sun's surface. For the first time across an astonishing 10 billion years, this visitor felt the intense heat of another star system's furnace. And then, just as suddenly, it went quiet. For 8 agonizing days, 3I-ATLAS was utterly obscured from Earth's view, perfectly aligned right behind the Sunday. Our most advanced telescopes were completely blind. Even the ground-based observatories, usually so reliable, were useless. This Manhattan-sized visitor, arriving from well beyond our solar system's boundaries, executed its crucial maneuver in complete undisturbed privacy. But here's the part that genuinely sends a chill down your spine. In those final moments before disappearing behind the solar glare, something fundamentally changed. The comet began to intensify its light at a terrifyingly rapid rate. Its glow spiked in a manner that vastly outpaced any natural comet we have ever cataloged. And its color, it shifted to a blue hue distinctly bluer than the sun itself. Let that single bizarre detail truly sink in for a moment. This object's outer shell should be frozen solid, hundreds of degrees colder than our local star. Yet somehow, impossibly, it was radiating light, exhibiting a color temperature hotter than the sun's own photosphere. Today, October 30th, the Punch satellite array finally managed to capture the initial imagery as 3I-ATLAS emerged from behind the solar brilliance. Officially, NASA's automated tracking apparatus confirms the comet maintained its expected orbital path. Absolutely no deviation, no abrupt course adjustment, no gravitational slingshot maneuver, no Oberth maneuver utilizing the sun's immense gravity to redirect toward Earth. At least that is what the data released to the public suggests. However, there are undeniable gaps, significant, crucial gaps. Rumor has it that NASA possesses ultra-high-resolution photographs captured by the Mars Reconnaissance Orbiter taken when 3I-ATLAS zipped within 30 million kilometers of the red planet back on October 2nd. Harvard astrophysicist Avi Loeb formally submitted a request for those specific images. The response: complete radio silence. Furthermore, China's Purple Mountain Observatory, which had been tracking the object with great intensity throughout August and the beginning of September, abruptly ceased publishing any further data, immediately following that Mars flyby. Their official justification cited scheduling overlaps with ongoing lunar missions. Curious timing, wouldn't you agree? This isn't some paranoid fantasy concocted to fuel baseless worry. This is about missing components in a cosmic puzzle that refuses to assemble neatly. Because even stripping away those potentially hidden images, what remains observable already defies any comfortable standard explanation. I'm going to walk you through precisely what transpired during that perihelion event. What altered, what remarkably stayed the same, and what continues to make absolutely zero intuitive sense. But before we delve into the solar obscuration, we absolutely must understand the object's provenance. And I'm not referring to some distant star system. I mean something far more profound and ancient. The available data strongly suggests 3I-ATLAS is approximately 10 billion years old. Think about that against our own cosmic timeline. Our entire solar system is merely 4.5 billion years old. This object was already floating in the void before our sun even sparked to life, long before Earth coalesced, before anything we currently recognize in our local stellar neighborhood even existed. This isn't just a visitor from another star. It seems to be visiting from another entire era of the universe's history. Contemplate that chronology. When 3IATLAS originally formed, the universe itself was less than half its present age. The very first massive stars had already lived out their dramatic lives and collapsed. Our Milky Way galaxy was still being violently sculpted by massive mergers and collisions. And somewhere within that immensely ancient cosmos, this object took shape. What conditions are required to forge a comet that somehow manages to endure for 10 billion years? How does something maintain structural integrity through that immense stretch of time? Through near-miss gravitational interactions with countless stars, through enduring the radiation from multiple stellar nurseries, through the crushing emptiness of deep interstellar void? The logical answer should be, it doesn't. Natural comets are inherently ephemeral. They are fragile, icy dust balls held together by relatively weak intermolecular forces. Time inevitably degrades them. Radiation constantly erodes their surfaces. Gravitational tugs from passing stars tear them apart. Yet here we have 3IATLAS, ancient beyond measure, perfectly intact, actively venting material as if it had only just formed moments ago. Now let's move on to the characteristics that render this object truly bizarre. We're setting aside speculation and filtering for only the raw, peer-reviewed, published scientific measurements, the concrete facts that professional astronomers struggle to dismiss with convenient answers. Anomaly number 1, its trajectory. 3IATLAS isn't just drifting into our solar system at some random angle. Its orbital plane aligns with the ecliptic, that flat disk where all our planets orbit, to within an astonishing 5 degrees. The sheer statistical odds of this alignment happening purely by chance are approximately 0.2% or 1 in 500. But it gets noticeably weirder. Its arrival timing was perfectly orchestrated to bring it within mere tens of millions of kilometers of Mars, Venus, and Jupiter. Crucially, it positioned itself precisely behind the Sun, rendering it invisible from Earth during its perihelion passage. The probability of all these alignment factors occurring naturally, a staggering 5 in 100,000. One could reasonably argue coincidence. The universe is vast, and strange alignments happen. That's fair enough. Let's proceed. Anomaly number 2, the sunward jet. Between July and August, several independent observatories, including the venerable Hubble Space Telescope, documented something completely unprecedented. 3IATLAS was actively ejecting material directly toward the Sun, not away from it, as every single normal comet is observed to do. Comets develop tails because the pressure exerted by solar radiation pushes gas and dust outward, away from the central heat source. That is fundamental physics. The tail always points away from the star, unless, of course, it doesn't. This wasn't an optical illusion caused by our viewing angle. Multiple telescopes viewing the object from disparate positions confirmed it. This sunward jet, which astronomers refer to as an anti-tail, persisted for weeks. Then, sometime in October, it simply vanished. The comet's plume abruptly shifted direction. Now it behaves as expected, venting material away from the Sun as physics dictates it should. What sort of physical mechanism permits a comet to completely reverse the basic direction of its gas expulsion? What caused that switch? Anomaly number 3, composition. When researchers analyzed the spectral signature of 3IATLAS's expanding gas cloud, they detected nickel. A significant amount of nickel, specifically 4 grams per second, continuously venting into space. In isolation, this isn't unheard of. Some comets do contain metallic compounds. But here is the core issue: there is almost no iron present. The ratio of nickel to iron is fundamentally incorrect, according to known natural cosmic abundances. In standard astronomical objects, iron is the dominant element, with nickel appearing only as a trace component. The specific ratio observed in 3IATLAS's plume precisely matches that of industrialized nickel alloys materials clearly manufactured by intelligent processes, not the result of natural stellar chemistry. The probability of this ratio appearing naturally is less than 1%. Furthermore, the ratio of nickel to cyanide is orders of magnitude higher than any comet we have ever seen, including Borisov, the only other confirmed interstellar visitor. The likelihood of that specific ratio arising naturally is also less than 1%. Anomaly number 4, water content. Standard comets are essentially giant ice balls. Water constitutes the bulk of their mass, typically 70 to 80%. 3IATLAS registers only 4% water. Yes, we detect water vapor. That's how we noticed its activity. But the actual reservoir of water is shockingly low compared to every other comet studied. What kind of comet contains so little water? Anomaly number 5. Extreme negative polarization. When sunlight reflects off the surface of 3IATLAS, it displays a polarization signature never before recorded in any comet, Borisov included. This measurement falls so far outside the established parameters that the statistical likelihood of it occurring randomly is again less than 1%. Anomaly number 6. The WOW signal connection. In 1977, the Big Ear radio telescope recorded an immensely powerful narrowband radio signal originating from deep space. It lasted 72 seconds. The signal was so potent, so clearly artificial in its structure, that astronomer Jerry Ahern famously scrawled, "Wow," in the margin of the printout. The source has never been identified. But here is the crucial link. 3IATLAS is traveling from a direction in the sky that aligns with the recorded origin point of the WOW signal to within 9 degrees. The probability of that overlap is 0.6%. It could be mere coincidence, another random outcome in an infinite universe, or perhaps not. When we mathematically combine the individual probabilities of these anomalies, the precise trajectory alignment, the perfectly timed arrival, the sunward jet, the skewed nickel ratio, the minimal water content, the extreme polarization, and the direction of the WOW signal origin, the cumulative likelihood of all these factors happening simultaneously through natural means drops to less than 1 part in 10 quadrillion. That's 1 in 10 quadrillion. To give you context, your odds of winning the Powerball lottery jackpot are 1 in 292 million. You would have to win that jackpot 34 million times consecutively just to match the odds of 3IATLAS being a natural object. So, we face a stark choice. Either 3IATLAS represents the luckiest cosmic coincidence in astronomical history, or something entirely different is unfolding here. To be perfectly clear, the doctrine of science demands that extraordinary assertions require extraordinary proof. Skepticism is the bedrock of the scientific method. The overwhelming majority of professional astronomers maintain that 3IATLAS is quite simply a natural object. A comet that formed in another stellar nursery was flung into the interstellar medium and is now passing through our system purely by chance. That conclusion is statistically the safest. Nature is incredibly inventive. The cosmos undoubtedly holds phenomena we haven't even conceived of yet. A lack of prior evidence doesn't equate to impossibility. But ignoring manifest anomalies doesn't somehow make them cease to exist. And what occurred during its close solar pass only amplified those existing anomalies rather than soothing them. Let me illustrate precisely what I mean. Space-based solar observatories managed to capture something truly extraordinary during the comet's final approach to the Sunday. Multiple independent instruments recorded the exact same event. The comet's brightness escalated at an exponential rate. This was not the gentle brightening expected from simple solar heating, nor the steady ramp-up caused by sublimating ices warming up. This was distinctly different, aggressive, unprecedented. Its brightness intensified inversely proportional to its distance from the Sun, raised to the power of 7.5. To translate that into comprehensible terms, as 3IATLAS drew nearer to the Sun, it didn't just brighten in a straight line. The escalation was exponential, far steeper than any Oort cloud comet observed at comparable distances. And remember, Oort cloud comets are pristine. They've spent eons in the deep freeze at the edge of our solar system. When they make their first plunge toward the Sun, they possess maximum volatile ice content and should outgas dramatically. 3IATLAS, with its 4% water, is ancient and depleted. It theoretically should not be capable of such a dramatic outburst. Yet there it was, blazing with increasing intensity, hour by hour. The stereo. A solar observation spacecraft captured simultaneous images using two separate tools, the Hi-1 heliospheric imager and the C2 coronagraph. Both clearly showed the comet developing an immense halo of light stretching 300,000 kilometers outward from the nucleus. 300,000 kilometers. That distance is almost the entire span from Earth to our moon. That is unequivocally not a standard cometary coma. That indicates something altogether different. The SOHO spacecraft, positioned at the Sun-Earth Lone Lagrange point, independently verified this observation using its LASCO coronagraph. Independent confirmation across multiple instruments yielded the identical result. Then came GOES-19, the newest weather satellite equipped with the CCR-1 compact coronagraph. It resolved structural details the others missed. The 300,000-kilometer halo wasn't a uniform glow. It displayed distinct layering complexity and discernible organization. But this is where the situation spirals into true strangeness, the color. When researchers analyzed the spectral data from both LASCO and CCR-1, they found something that should be physically impossible. The light emanating from 3IATLAS was demonstrably bluer than the sun itself. Stop and consider the ramifications of that finding. When sunlight reflects off a comet, it should match the sun's color, perhaps slightly reddened by dust. When a comet heats up and glows due to thermal emission, it should emit light shifted toward the red or infrared end of the spectrum, cooler than the sun, not hotter. The surface temperature of 3IATLAS, even at its closest solar approach, should register hundreds of degrees Kelvin lower than the sun's photosphere. The sun's surface temperature clocks in at 5,800 Kelvin. That's what generates its characteristic yellowish white appearance. For 3IATLAS to appear bluer than the sun, its light source would need to be substantially hotter. We are discussing temperatures simply not achieved on the surfaces of natural comets. So where is this blue light originating? The research paper published on October 28th by scientists Zhang and Datum states plainly, the reason for 3IATLAS's rapid brightening, which far exceeds the brightening rate of most Oort cloud comets at similar distances from the sun, remains unclear. Regarding the blue coloration they note, it suggests emission contributes a substantial fraction of the overall visible brightness. Emission, not reflection. Something on or within 3IATLAS is actively generating light at high temperatures. What natural process accounts for that? What kind of comet possesses an internal thermal engine hot enough to produce blue light? The authors offer no explanation because a comfortable one does not exist within established astrophysics. You might propose an alternative. Could this be fluorescence gas molecules excited by intense solar ultraviolet radiation, then re-emitting light at shorter wavelengths? It is technically possible. Some cometary gases like cyanide compounds can indeed produce a blue-green emission, but the scale is wrong. Fluorescence typically results in faint, subtle glows, not a brightness level that dominates the entire observed spectrum. Moreover, the observed blue shift was far too pronounced for fluorescence to account for it entirely. Perhaps it's reflected light off a surface that is impossibly bright and perfectly icy. Again, the scale defies this. And crucially, 3IATLAS is ancient. Its surface should be battered and darkened by billions of years of cosmic ray exposure, not mirror bright. The data simply does not align with existing models. When data refuses to fit established models, science offers three pathways. 1. The data collection method is flawed. 2. The existing model is fundamentally incorrect. 3. Something genuinely unexpected is occurring. Let's grant the first option. The data is accurate. Multiple independent instruments operated by different international teams yield identical readings. Dismissing this as measurement error is extremely difficult. Therefore, either our foundational understanding of cometary physics is incomplete, or 3IATLAS is executing actions that comets simply do not perform, such as powering an internal energy source. I am not asserting that it is a power source. I am merely stating that the empirical observations are entirely consistent with that specific hypothesis. An engine producing heat technology, maintaining functionality across 10 billion years of operation. A craft designed to exploit solar flybys for periodic energy, recharging. Pure conjecture. Absolutely. But let's explore that thought experiment. If you were engineering an interstellar probe intended to survive for billions of years, how would you design it? You would require extreme durability, redundant systems, and periodic energy replenishment because even the most efficient power source degrades over geological timescales. Stars are perfect refueling points, predictable and immensely powerful. A close pass to a stellar surface dumps colossal amounts of energy onto any absorbing surface. If 3IATLAS were technological, a perihelion transit would be the optimal moment to recharge, absorb solar radiation, convert it to usable power, and perhaps even leverage the gravitational well for a necessary trajectory. Adjustment. However, that's not what the public data shows. According to NASA's automated systems, the object maintained its calculated trajectory. No adjustment, no course correction. It swept in, looped around, and continued outbound precisely where standard gravitational physics predicted it should go. So, if it is a probe, it seems demonstrably uninterested in our planet. It's not adjusting its path to investigate Earth. It's adhering to a pre-programmed route, briefly dipping into our solar system, perhaps gathering stellar data before continuing its seemingly endless journey across the galaxy. Or, more probable in the context of Occam's razor, it's just a phenomenally strange comet. But that blue light, it keeps pulling at the edges of logic. And there's another crucial timing detail that doesn't integrate well into the natural comet narrative. Remember the sunward jet, that baffling anti-tail that defied physics throughout July and August. That jet ceased existing sometime in October, coinciding precisely with 3IATLAS passing Mars and immediately preceding its solar occultation. When it reappeared on October 30th, the plume had normalized. It now exhibits the behavior of a standard comet tail pointing away from the sunday. The anomaly fixed itself, or it was fixed. This is precisely where we encounter the information quarantine. China's tracking observations ceased immediately after the Mars flyby. NASA has withheld the high-resolution imagery from the Mars Reconnaissance Orbiter. The object was intentionally hidden behind the Sun during its most critical phase of activity. What we have is distinct before and after snapshots. Before perihelion, we saw anomalous activity, the sunward jet, the bizarre composition. After perihelion, we observe a normalized tail, continued outgassing, and a retained trajectory. What happened during those 8 days of invisibility? We know that Congresswoman Anna Paulina Luna is actively pushing for the release of those high-resolution Mars images. Avi Loeb has been very public about demanding greater transparency. Radio observatories are now dedicating time to monitoring 3IATLAS following Loeb's request to specifically search for any artificial electromagnetic emissions. Thus far, the results are negative. No transmissions, no discernible technology signatures, just a comet behaving like a comet, albeit one with traits we've never encountered before. The JUICE spacecraft, currently en route to Jupiter, is scheduled to observe 3IATLAS on November 2nd and again on November 25th. It carries 5 instruments: a camera, a near-infrared imager, a UV spectrometer, a sub-millimeter sensor, and a neutral atom detector. JUICE is currently positioned half an astronomical unit away from the comet, which translates to 75 million kilometers. That's too distant for detailed imaging, but sufficiently close for valuable spectroscopy and compositional mapping. However, the data downlink won't occur until February 2026 because JUICE's position relative to Earth results in painfully slow transmission rates. So we wait again. More voids in the narrative. What we can confirm is that 3IATLAS successfully navigated perihelion without fragmenting. Some astronomers had predicted thermal stress might tear the object apart. Comets are inherently fragile, and the solar pass can be devastating, especially to loosely aggregated rubble piles. 3IATLAS refused to break. Despite being subjected to 770 watts per square meter of solar energy at its closest approach, despite the immense tidal forces near the Sun, and despite its 10 billion years of assumed cosmic weathering, it remained structurally whole. This offers a vital clue regarding its internal makeup. It is not a loosely bound pile of ice. It possesses structural integrity, strength, and powerful cohesion. One could argue this simply proves it formed as a monolithic body, a single solid frozen mass rather than an accretion of smaller pieces. That is a perfectly normal formation mechanism for some comets. Or, one could point out that 10 billion years is an extraordinarily long time for any natural structure to maintain perfect coherence. Micrometeorite impacts alone should have fractured and eroded its surface over that timescale. Cosmic ray damage should have inherently weakened its internal bonds. Yet here it is, intact, functional, venting gas like a newborn comet despite possessing only 4% water ice. Let me introduce another critical data point, one that Avi Loeb highlighted during his discussion on the Joe Rogan podcast. The nickel expulsion rate, 4 grams per second, sustained for months. Let's calculate that. From its July discovery until the late October perihelion, that's approximately 4 months, or roughly 120 days, equating to 10 million seconds. 4 grams per second multiplied by 10 million seconds totals 40 million grams. That's 40,000 kilograms, or 40 metric tons of pure nickel vented into the void from an object estimated to be around 5 kilometers in diameter with a total mass approaching 30 billion kilograms. 40 tons of nickel constitutes roughly 1/millionth of its total mass. That might not sound significant, but remember, this is gaseous ionized nickel present in the plume, not nickel bound within silicate minerals or trace elements locked in rock. Normal sublimation cannot achieve this. Nickel boils at nearly 3,000 degrees Celsius. The surface of 3I/ATLAS, even at perihelion, never reaches temperatures high enough to vaporize metallic nickel. This requires an energy input, a massive one, either from an internal reactor or from some exotic surface chemistry we are totally ignorant of. And that nickel-to-iron ratio remains cosmically incorrect. Stellar nucleosynthesis creates iron and nickel together in specific balanced proportions. Finding nickel abundantly, without corresponding iron, is akin to detecting smoke without any source of fire. Unless, of course, the nickel isn't sourced from native ore, but rather from manufactured components, structural alloys, specifically designed for certain mechanical properties. I understand how this sounds. I truly do. We are engaging in pattern recognition, projecting design onto randomness, a cognitive trap humans are hardwired to fall into. We seek intention behind highly unusual events. But sometimes those unusual events are intentional. The difficulty lies in separating the two, and right now, with data-suppressed observations hidden and timeline gaps, we are operating with an incomplete map. This leads us to the enormous, unavoidable topic I've been carefully circling. What if this object is artificial? What would that imply for humanity? Let's consider scale for a moment. Our most advanced current creation, SpaceX's Starship, stands 120 meters tall and can lift 100 tons into low Earth orbit. It represents the zenith of human rocketry. 3I/ATLAS is 5,000 meters across, perhaps even larger, with an estimated mass of 30 billion kilograms. That's 300 million times heavier than Starship's maximum payload capacity. If 3I/ATLAS represents technology, its creators would have mastered capabilities so far beyond our comprehension that direct comparison becomes absurd. We are discussing a civilization capable of constructing mountain-sized objects, accelerating them to true interstellar velocities, and maintaining their operational status for 10 billion years. 10 billion years. Human civilization is perhaps 10,000 years old. Recorded history spans maybe 5,000 years. Our entire species, Homo sapiens, has walked this planet for only 300,000 years. 10 billion years ago, Earth was non-existent. The sun had not ignited. The molecular cloud destined to form our entire solar system hadn't even begun its gravitational collapse. Any intelligence capable of engineering 3I/ATLAS would have originated in a younger, far stranger universe. They would have witnessed cosmic evolution on scales we can barely visualize. They would have solved engineering problems we haven't even formulated yet. And if they sent out probes, why wouldn't those probes be built to endure, to observe, to gather data across vast geological epochs? Avi Loeb makes a compelling argument: the confirmation of technological artifacts from an alien civilization would instantly become the single most significant revelation in human history. It would decisively answer the oldest question: are we truly alone? The implications stretch far beyond philosophy. If interstellar probes are feasible, if they are numerous enough that one passes through our solar system every few decades, then the galaxy might be teeming with them. Ancient observers, silently mapping the stellar neighborhood, relaying information back to civilizations that might have perished eons ago or that still thrive. Consider that possibility for a moment. As you absorb this information, there could be billions of automated probes scattered throughout the Milky Way, silent witnesses to the birth and demise of stars, to the formation of planets, to the genesis of life. Some of those silent observers might even be focused on us right now. But let's recalibrate, pulling back from wild conjecture and returning to measurable facts, the observations we can test and verify. The International Asteroid Warning Network has formally launched a dedicated monitoring campaign focused solely on 3IATLAS. Beginning November 27th and continuing through January 27th, 2026, numerous global observatories will coordinate their efforts. This campaign includes specialized workshops on astrometry, the meticulous charting of celestial positions and movements. Why? Because tracking potentially hazardous objects demands absolute precision. 3IATLAS, while posing no threat to Earth, serves as the perfect trial run. It is large, bright enough for continuous observation, and its interstellar trajectory presents unique difficulties for tracking software. But there is an unspoken secondary reason for this intense tracking. If 3IATLAS were to make any course adjustment, even a minute one, this coordinated network would immediately detect it. Any deviation from the purely gravitational path would be instantly flagged. So far, zero deviation. The object continues on its predicted ballistic trajectory. No thrust, no corrective burns, just gravity doing its work. That, incidentally, stands as strong evidence against the technological hypothesis. Probes maneuver. They adapt to their environment. 3IATLAS is exhibiting none of that behavior. Or perhaps it already executed its maneuvers centuries or millennia ago. Once an object is placed onto the perfect interstellar transit path, why waste precious energy on further adjustments? Simply coast, observe, record, and proceed. The upcoming observations scheduled for December will be crucial. On December 19th, 3IATLAS will achieve its closest orbital proximity to Earth, 269 million kilometers. That's nearly double the distance between Earth and the Sun, but it is the closest pass we will get. Ground-based telescopes will enjoy optimal viewing angles. The Hubble Space Telescope will devote observation time. The James Webb Space Telescope will participate. Every significant observatory on the planet will direct its instruments toward this visitor. They will dissect its spectrum with unmatched detail, attempt to map any surface features, measure its spin rate, and diligently search for any hint of internal structure or thermal signatures that cannot be attributed to solar heating. And they will listen. Radio telescopes across the globe will scan 3IATLAS for any non-natural electromagnetic output. Any signal, any repeating pattern, any deviation from random thermal noise. If this is a probe, December may expose it. If it is transmitting status reports back to its origin, we might intercept that data stream. If it is using active sensors to scan Earth, we might detect the resulting radar or LiDAR pulses. But we must consider the uncomfortable possibility. What if the object is engineered specifically not to be detected? What if it has been perfectly disguised to mimic a natural comet? Passive operation, minimal emissions, camouflage that is indistinguishable from the real thing. How would one even test for that? How do you definitively prove the absence of technology when the technology itself is designed to perfectly mimic the natural? You can't not definitively. You can only accumulate evidence and search for the cracks where the disguise fails. and 3IATLAS currently exhibits 9 inconsistencies. If we include the blue light emission, we have 9 separate anomalies that defy simple, comfortable explanations. However, 9 anomalies do not constitute conclusive proof. They constitute a profound mystery, and mysteries often possess mundane resolutions. Let me propose a natural scenario that manages to account for the majority of these observations. Assume 3IATLAS isn't a standard comet at all. Perhaps it is something far rarer, a fragment ejected from a catastrophically disrupted planet, a shard of a world torn apart by immense tidal forces during a close encounter with a star billions of years ago. Planetary fragments would possess radically different compositions than icy comets. They would contain substantial metallic core material, including nickel-iron alloys. If 3IATLAS is such a fragment, the prodigious nickel venting becomes understandable. It's venting material from deep within the original planetary interior, exposed by the shattering event. The scarcity of water is also explained. Planetary cores are exceptionally dry compared to cometary ice reservoirs. The structural resilience is accounted for solid rock and metal, not soft, fluffy ice. The 10 billion year age is feasible as planets form early in stellar system evolution and fragments could survive long journeys. What about the blue light? If the fragment contains highly radioactive isotopes, the internal heat generated by radioactive decay could drive unique chemical reactions on the surface, producing emission lines we don't typically associate with cometary activity. The sunward jet could be explained by localized venting driven by internal pressure through structural fissures aimed outward based on the fragment's rotation and weak points. See, a coherent, natural narrative can be constructed. It demands a highly specific confluence of rare events, yes, but those events are not physically impossible. Unlikely, perhaps, but not impossible. The core scientific question then becomes, which is the more probable explanation? A rare natural astronomical remnant possessing multiple highly unusual properties, or the tangible product of an ancient extinct civilization? Most working scientists would lean toward the natural explanation, no matter how improbable, because we possess 0 confirmed instances of extraterrestrial technology, whereas we have billions of examples of natural objects behaving strangely. Prior probability heavily favors nature. Extraordinary claims require extraordinary evidence. And presently, our evidence remains circumstantial, suggestive, intriguing, but far from definitive. So where does this leave us? In this final week of October 2025, we continue to watch, we wait patiently, and we gather every scrap of data. We must prepare for both potential outcomes. If 3IATLAS proves natural studying, it will fundamentally reshape our understanding of planetary accretion, stellar dynamics, and interstellar object composition. It is a messenger from the universe's infancy, carrying chemical records from environments and processes that no longer exist in our relatively modern cosmos. If 3IATLAS proves artificial, well, then everything changes instantly. The Fermi paradox transforms from a philosophical riddle into a confirmed solved mystery. We are not isolated. We were never alone. The galaxy harbors or once harbored intelligence capable of traversing the vast gulfs between stars. And if they achieve that capability eventually, so can we. But here is what concerns me most about the artificial hypothesis. If 3IATLAS is a monitoring probe, it appears utterly uninterested in us. It passed Mars within 30 million kilometers, close enough to map the surface features in high definition, close enough to detect our rovers, our satellites, and our existing infrastructure. If it intended to examine Earth, it had ample opportunity. A minor trajectory tweak during the Mars flyby would have placed it in a much closer orbit around our planet. Instead, it maintained its calculated course. It prioritized its solar rendezvous over a close-up inspection of Earth. What kind of probe behaves that way? What alien intelligence would find surveying a star system's primary star more valuable than investigating a nearby planet hosting a technological civilization? Unless, of course, it already knew we were present. Unless it had scanned us from a distance and rationally determined that we weren't worth the energy expenditure for a closer survey. Or perhaps Our planet wasn't its designated target. Maybe its mission was strictly solar system survey, gathering astrophysical data, not biological or sociological data. Or maybe, just maybe, it did investigate us. Perhaps it deployed smaller, unnoticeable sub-probes during the Mars flyby miniature observers now stationed in an orbit around Earth, recording logging data and patiently waiting. This is pure speculation, sliding deep into science fiction territory. But reality has repeatedly proven itself far stranger than fiction. Black holes were once theoretical concepts. Neutron stars sounded impossible. Galactic collisions were unimaginable until we observed them. Reality continually surprises us with phenomena we couldn't predict. Why should ancient probes traversing the galaxy be off the table? The answer might arrive soon. December 19th is the key date. Its closest approach to Earth. Optimal viewing geometry. Maximum allocation of instrument time. If any secret is to be revealed, that is when it will occur. Imagine the headlines on December 20th: Webb telescope detected unexpected heat signatures, or Hubble imaged geometric surface structures, or radio observatories finally locked onto a coherent signal. Confirmation that we are not unique, that intelligence pervades the cosmos, that the universe is in fact alive with civilizations, building, exploring, and reaching across the void. Now imagine the counter scenario. December 20th. All observations are consistent with natural cometary physics. The anomalies are successfully explained by unusual, though non-artificial physical processes. 3IATLAS is scientifically fascinating, ancient and valuable, but ultimately just a rock and ice ball. The world collectively sighs, moves on, and the interstellar visitor fades back into the realm of forgotten trivia. Which outcome do you personally hope for? Which do you genuinely expect? I confess, I don't know what I wish for. The romantic core of my being desires 3IATLAS to be artificial, to confirm that we belong to a greater cosmic community, that intelligence is not a rare fluke. But the rational scientist in me recognizes the monumental disruption. Contact, even passive discovery of an artifact, fundamentally alters everything. Our place in the cosmos shifts, our priorities realign. Questions of purpose and future take on terrifying new dimensions. And there is a layer of fear. If they are indeed out there building objects that survive billions of years, why the profound silence? If probes are common, if Atlas is only one of countless others, why this universal quiet? Are we being watched, cataloged, filed away in some galactic archive of nascent civilizations, simply waiting to see if we survive long enough to become relevant? Or is 3IATLAS something even more poignant? A derelict, a ghost ship from a civilization that vanished before our sun was born. Alone now, eternal, running on autopilot, reporting to masters who no longer exist. That fate feels almost sadder than being solitary. Knowing they existed, knowing they built wonders, and that only their automated remnants continue their programmed paths. But these are emotional responses, not rigorous analysis. What matters is the data, the incoming stream of measurements and observations arriving week by week, instrument by instrument. We are compiling the most comprehensive scientific dossier ever assembled for an interstellar visitor. By the time 3IATLAS departs the inner system, we will know more about it than we know about many comets native to our own Oort cloud. We will possess spectroscopy, photometry, polarimetry, radio profiles, thermal maps, optical imagery, and compositional analyses. From that, wealth of data patterns will emerge and the answers will begin to crystallize. The anomalies will either resolve into natural explanations, or they will persist as genuine, profound scientific enigmas. December 19th is the keystone date. Maximum observation time, optimal geometry. If any revelation is forthcoming, that is when it will be presented. Let's step back one last time and look at the broader context. Since 2017, we have detected 3 confirmed interstellar objects traversing our solar system. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025. 3 objects in 8 years. Statistical modeling indicates that our current detection capabilities capture only a minuscule fraction of the true population. For every visitor we spot, thousands pass by unnoticed, too small, too dark, or simply on an unfavorable vector. The galaxy might be thick with interstellar debris, planetary shards, ejected comets, cosmic grit drifting between the stars, occasionally captured by a passing stellar gravity well. We are only now developing the requisite technology to see them: improved telescopes, automated sky surveys, advanced tracking algorithms. As our sight sharpens, we will find more. And each one will be a deep time capsule, a sample of a radically different stellar environment, a piece of stellar history delivered directly to our neighborhood. Here is the truly fascinating deviation. Oumuamua was strange, anomalous acceleration, peculiar, non-spherical shape, a surface that defied expected composition. Borisov was perfectly normal, a textbook comet displaying the water, ice, and carbon compounds we predicted an interstellar comet should possess. And now Atlas is strange again, loaded with baffling inconsistencies that defy standard models. 2 out of the last 3 interstellar visitors have been exceptionally weird. Is this just poor statistical sampling? Or does it suggest that cosmic weirdness is far more common than we previously estimated? If weirdness is common, why? Is it the environment of their birth, the ejection mechanism, or is it something else entirely? Could a small, perhaps even a non-trivial fraction of these interstellar objects be artificial? Not the majority. Certainly not all, but some. If intelligence arises frequently across the Milky Way, and if those intelligences construct probes to map their stellar neighborhood, then over cosmic history, the sheer accumulation of these artifacts would be astronomical. Imagine one civilization launches 10,000 probes. They traverse the galaxy for millions of years before that civilization vanishes, but the probes persist. Then another intelligence arises, launches its fleet, and eventually disappears too, leaving its automated vessels in transit. Across galactic time, millions of civilizations could have risen and fallen, each potentially adding to the inventory of interstellar probes. By now, ancient artifacts might actually outnumber natural interstellar objects in certain regions of the galaxy. This is the core hypothesis Avi Loeb consistently promotes, not because he is certain it is true, but because it is eminently testable. You search for signatures, you analyze the anomalies, you build a body of evidence that either supports or contradicts the possibility. And if even one interstellar object is confirmed as artificial, the entire framework of human existence shifts. The Fermi paradox dissolves. The concept of the Great Filter becomes significantly less terrifying because at least one intelligence has achieved the capacity for interstellar construction. We are not necessarily alone. We are not necessarily destined for self-destruction. The universe has proven that intelligence can evolve, develop technology, and reach for the stars. That possibility alone warrants the telescope time, the intense analysis, and the scientific scrutiny, because the payoff, if verified, is literally immeasurable. But even if 3IATLAS is purely natural, its scientific value is enormous. We gain direct insight into planetary formation processes operating in entirely different stellar systems. We study material that has undergone alien chemical processes, experienced different thermal histories, and followed different evolutionary paths. Every measurement refines our current models. Every spectrum adds a critical data point. Every observation deepens our comprehension of the sheer diversity embedded within the cosmos. And that knowledge has practical applications. Understanding exoplanet evolution informs our search for life. Studying cometary origins helps trace the delivery of water and organic molecules to Earth. Grasping interstellar dynamics aids in charting the galaxy's structure and history. Science advances incrementally brick by measured brick. 3IATLAS is one more brick in that massive edifice, unusual, anomalous, certainly, but intrinsically part of the grand construction of human understanding. So, what should you retain from this ongoing saga? What is the guiding principle? First, devote intense attention to the anomalies. When data stubbornly refuses to conform to expectation, that is precisely where true discovery lies. That is where our existing conceptual models must be broken down or rebuilt. Simple answers are comforting, but nature remains indifferent to human comfort. Second, maintain skepticism, but remain fundamentally open-minded. Extraordinary claims demand extraordinary proof, but the evidence itself can become extraordinary if you collect enough of it patiently. Do not discard possibilities merely because they feel improbable. Calculate the odds, rigorously test every hypothesis, and pursue the data wherever it leads. Third, the universe is demonstrably stranger than our most ambitious science fiction writers can imagine. Black holes seemed fantastical until we physically detected them. Exoplanets were theoretical until we cataloged thousands. Gravitational waves were mathematical predictions until the LIGO detectors finally registered the cosmic ripple. Reality consistently surprises us. What sounds impossible today may well be standard textbook material a decade from now. Fourth, we are living in an unparalleled golden age of observational astronomy. We possess superior telescopes, advanced instrumentation, rapid data processing capabilities, and robust international collaboration. For the first time in our species' history, we can actively track objects originating from other star systems in real time. We can analyze their physical makeup, measure their properties, and test profound hypotheses about their origins. Our ancestors couldn't have dreamed of this capability, but we possess it right now, and 3IATLAS is merely the vanguard. More interstellar visitors are inbound. Detection systems are continuously improving. Within the next decade, we may be tracking dozens of these wanderers. Within a century, we might launch our own intercept missions to study them up close. The galaxy is slowly, deliberately revealing itself to us. Every year, our vision extends further, our understanding deepens, and we uncover wonders we couldn't have conceived of previously. So, when 3IATLAS eventually dims from view, receding back into the interstellar dark that briefly illuminated it, that won't be the conclusion. It will be a single pivotal chapter in an ever-expanding library of cosmic encounters. And perhaps, just perhaps, one of those encounters will be the defining moment, the one that definitively confirms we are not alone, the one that answers humanity's most enduring question: is intelligence unique to Earth? The answer may be approaching. Not necessarily this year, but soon, perhaps, within our lifetimes, potentially. As we observe more, detect more, and analyze more complex data, the probability of finding evidence of other civilizations inches upward. When that moment arrives, if it arrives, I hope we are prepared. Prepared for the philosophical upheaval, ready for the reorganization of our global priorities, ready for the fundamental transformation of perspective that accompanies the true knowledge that intelligence thrives beyond our blue sphere. But until then, our duty remains clear. We watch the skies, we calibrate the instruments, we collect the photons, we construct the models, test the limits of those models, and we never stop wondering. Because that spirit of curiosity, that inherent human drive to explore, to push boundaries, to question the void, is what propels all scientific progress. It is the possibility that something extraordinary might be real, that the universe is richer, more populated, and more alive than we previously dared to imagine, that keeps our telescopes pointed upward. Right now, as of October 31st, 2025, 3IATLAS is accelerating away from the sun at 210,000 kilometers per hour. Each subsequent hour carries it further from the brief warmth that characterized its stay. Each day it grows colder, darker, more remote. It is currently past Mars's orbital path, but that transit will be fleeting. By mid-November, it will cross the Martian orbit entirely and continue its outward recession. By December, it will be brushing the outer reaches of the asteroid belt. By the close of 2026, it will pass Jupiter's orbit and begin its long, slow return to the deep, cold interstellar medium. And we will be watching every second of that departure. The viewing conditions for Earth-based instruments are improving rapidly. During perihelion, the object was lost in solar plasma, observable only by specialized space-based instruments. Now, as the angular separation between the comet and the sun widens, conventional telescopes are gaining access. Starting this very weekend, amateur astronomers equipped with decent gear will be able to locate 3I/ATLAS low in the pre-dawn sky tracking near Venus as it rises just before dawn. It won't be visible to the naked eye, but through a telescope you can pinpoint at a faint, fuzzy smudge of light. A visitor from another star system close enough to be captured in a photograph taken from your own backyard. That fact in itself is astonishing when you stop to reflect. How many generations have gazed into the night, yearning to touch something from another world, and now you can aim a telescope at 3I/ATLAS and directly observe an object that initiated its journey before our sun even flickered into existence. You are gathering photons that have physically interacted with material forged under alien stellar conditions. You are witnessing in near real time a genuine sample of an alien cosmic environment. Professional networks are fully engaged. The European Southern Observatory, utilizing its massive array in Chile, will maintain continuous tracking throughout November and December. The Keck Observatory in Hawaii will observe. The Very Large Telescope will contribute data. Subaru, Gemini, Magellan, every major facility is dedicating time. They seek specific spectral signatures, changes in brightness that might signal active venting episodes, variations in the spectrum, indicating surface compositional differences, and polarization readings that reveal particle sizes within the coma. Above all, they are hunting for anything unusual, any departure from expected dynamics. Any hint that 3I/ATLAS harbors more complexity than meets the eye? The Hubble Space Telescope has already provided critical imagery. Its capture in July of the sunward jet remains the single most debated photograph, the visual evidence of that anti-tail. Hubble is scheduled for more sessions in December, utilizing multiple filters at maximum resolution. These images should reveal surface topography, if any exists, map the distribution of dust ejected by the jet, and precisely measure the rotation period. Crucially, they will compare these December findings against the July baseline. Has the surface topography altered? Have new vents appeared? Has the pattern of activity fundamentally shifted? The James Webb Space Telescope will focus its powerful infrared gaze. Webb detects heat, which is ideal for studying cold cometary bodies. Infrared reveals thermal mapping, compositional specifics, and subsurface probing. Webb will map the temperature gradient across 3I/ATLAS's surface, identifying hot spots or unusually cool regions that suggest non-solar energy input. If an internal heat source exists, Webb is the instrument most likely to pinpoint it. The SPHEREx Space Observatory already confirmed the carbon dioxide plume back in August, precisely measuring the gas cloud's velocity and overall composition. SPHEREx will reobserve in December, tracking changes. Is the CO2 production rate accelerating or slowing? Is the nickel vapor still being expelled? What about that meager 4% water vapor? Is that concentration holding steady, or is the reservoir depleting at a measurable rate? These are not minor details. They speak directly to the object's interior dynamics and the source driving its outgassing. Is it merely solar heating, or is an underlying mechanism contributing energy? Radio observatories are all listening intently. The Very Large Array in New Mexico successor facilities to Arecibo, and even instruments associated with the SETI Institute, are locked onto 3I/ATLAS, scanning the electromagnetic spectrum for narrowband signals, repeating patterns, or anything that deviates from the expected thermal noise of a comet interacting with the solar wind. Avi Loeb specifically championed this radio monitoring, arguing that ruling out an artificial transmission is a mandatory step. If the object is transmitting even weakly, we should detect it from our current separation. To date, silence. The Chinese space program, having gone quiet post-Mars flyby, still maintains significant assets. Their deep space network remains fully operational, capable of observing 3I/ATLAS, should they choose to dedicate bandwidth. Whether that data is shared remains an open question, underscoring an uncomfortable reality of modern astrophysics. Data often becomes national strategic assets when monumental discoveries are at stake. If China observes something truly exceptional in September, would they release it immediately or classify it while they analyze its potential advantages? The same question applies to the US regarding those Mars Reconnaissance Orbiter images. Is the delay truly bureaucratic friction? Or is NASA exercising extreme caution before releasing visuals that could irrevocably alter global perception? Congresswoman Luna's efforts suggest the pressure for transparency is escalating. Scientists and the public demand the data, but institutions move deliberately when the implications are world-changing. We will discover the truth eventually. Data has an unfortunate habit of escaping institutional control. An astronomer will present images at a conference. A researcher will post preliminary findings online. The truth, whatever form it takes, will emerge. But while we await that emergence, the observation cascade continues. Every telescope, every instrument, every wavelength is being deployed, constructing the most exhaustive data set ever compiled for any interstellar visitor. By the time 3IATLAS finally escapes the inner solar system, we will possess more verifiable information on it than we do on numerous comets born in our own backyard. And from all this collected evidence, patterns will solidify and answers will emerge. The mysteries will either resolve into natural explanations or they will persist as genuine, verifiable scientific impossibilities. December 19th, the closest approach to Earth, will be the moment of maximum observational leverage. If something is to be confirmed, that will be the time. Imagine the breakthrough. Webb detects impossible heat signatures, or Hubble reveals geometric architecture on the nucleus, or the VLA locks onto a coherent artificial broadcast. The headlines will write themselves. Confirmation that we are no longer the sole intelligence in the universe. The galaxy is populated, or was populated, by builders and explorers. But if the alternative occurs, if the data confirms an entirely natural, albeit incredibly strange origin, the world will absorb the news perhaps with momentary awe and then move on, concluding that the grand question remains unanswered for now. Which outcome do you find more compelling? Which outcome do you anticipate? I remain conflicted. The explorer in me desperately wants 3IATLAS to be artificial, to signal that we are participants in a vast, living, cosmic ecosystem. But the rationalist acknowledges the inherent instability that even passive contact implies. Our species' self-perception shifts instantly. Furthermore, that lingering question persists. If probes are common, why the universal silence? Perhaps we are being monitored, filed away as a footnote in some ancient galactic ledger awaiting a survival threshold we have not yet met. Or perhaps the probe is a relic, a functional derelict from a civilization that collapsed 10 billion years ago, forever wandering the darkness on autopilot, reporting to masters long turned to cosmic dust. That scenario might be the most melancholic of all. These are emotional considerations, not data points. What counts is the evidence now accumulating. We are building the scientific foundation that will lead to a consensus regarding 3IATLAS's nature by February 2026, when the JUICE data finally arrives and the December observations are fully processed. My professional prediction is that it will resolve as natural, an ancient, compositionally bizarre planetary fragment ejected billions of years ago by a long-dead star system now passing through by cosmic accident. But I could be profoundly mistaken. The universe excels at surprises. And wouldn't it be the ultimate surprise if this time the enigma we uncover is in fact intelligence? Stay curious, stay skeptical, stay open, and keep watching the skies, because the next fuzzy patch of light we spot might be the one that finally tells us the truth. If you find this content interesting, please like and leave a comment. This video from Cosmic Warning A to Z, thank you for watching.